Welcome. Today we are going to be talking about DevOps moving into production. And I was sitting in the keynotes this morning and I heard something that just made me jump up and down and tweet, right? That, code doesn't really have business value until it gets into production, until people are using it, whether that's internal people or external people. You got to get it into production, right? That's really kind of the problem, isn't it? Is getting it into production as fast as it's actually getting to where it's ready to go. So I am Lori MacVittie. I'm from F5 Networks. I know, it means nothing, right? It's just a name, right? So I usually don't do this, but this is a crossover session between dev and ops. So I thought I would, make sure, provide a little bit of background so you understand, yeah, I'm a crossover person, right? So I started out as a developer. That's my love, and that's what I like to do. I have sat on Saturday night in that change window waiting for my code to get into production and having it rolled back and then have to go home and do it again. I've had DBAs tell me that I can't put that query into production because it's not optimized. And I've had to sit through 15 manual signatures on a piece of paper to get a firewall rule into place. What's up with that? I still code, but not professionally. They don't like me to do that. I tend to do really strange things when I code, so they prefer I don't do that anymore. For the last probably 15 years, I've really been focused on networking instead, which is another interesting thing to look at. So I did a lot of test labs. We would build them up and tear them down. And when you put them up, they actually have to be kind of production quality. Because when you do a test, if there's anything wrong that somebody can find in the network, they will blame it. I've had software vendors galore tell me the network wasn't configured correctly. That route was wrong. There was an extra hop. You had the wrong this or that. Anything to get out of why we didn't perform as well as we should have. So networking is very important, and you have to get it right, which is a lot like production. So you're building them up, you're tearing them down, you're constantly doing these things. So we have a lot of experience going on with actually, automating things. For the last 9 years, I've been at F5 Networks, where I do technical marketing. I write things, I learn things, I study things. I watch for dev trends, I watch for ops trends. I generally just mouth off a lot and spout my opinion, and people say, okay, that's nice. Then they send me places here and say, well, go spout off to somebody else because we're tired of listening to you. So the goal of DevOps, really, when you're going into production, is to get from those maintenance windows that right now kind of rule the traditional enterprise to whenever. That's the promise of continuous deployment, is that we can continuously deploy things. We push a button, and the code gets built, and it goes through the process, and then it goes into production, and everything kind of happens, and voila. The code is out there, the app is downloaded, and your 8-year-old is jumping up and down. Okay? Unfortunately, we know that isn't actually how it works, at least not in a traditional enterprise. So how many of you guys are developers? How many of you guys are like ops guys, or you don't? Okay, see, we got about half and half. Look at you split, kind of. You don't want to bang into each other. Nothing too controversial? I'm going to think about that, because I might, and then I might not. I don't know. They said there were no tomatoes available this early in the morning, so I think I'm kind of safe there. So we'll see. But this is the goal, right, is to take all of the stuff that dev does, all of the continuous integration and the continuous delivery of applications, and start applying that to production so that you can move a little faster and you can get things out to the end user, whoever that might be. So when we talk about DevOps, this is another one of those. What does that mean? Is it something you do? Is it something that you buy? Is it something that you apply? Is it a set of best practices? The fathers, if you will, of DevOps say, well, right now it's kind of like philosophy. It's kind of this a theory, right? It's about culture. It's about sharing. It's about automation. And it's about measuring. So it's all a philosophy about how to put those things together and to come up with a way to kind of smooth out all of the bumps in the road that happen between writing that first line of code and the user actually doing something with it, whether it's for profit or productivity, right? Both are important to the business. So there's a lot of hype out there about what DevOps is. And this reminds me of me saying, you know what? I'm going to quit smoking next week. I have decided that I have heard so many great benefits about it, right? I can reduce my costs, right? I don't have to pay for these things anymore. I'm going to cut costs because it costs too much. There's health improvements, right? I'm going to be more healthy. I'm going to run faster. I'm just going to feel better in general. You know, I'm going to reduce my risk of all sorts of horrible things that might happen to me. I see those all the time on TV. So I've heard all of these things. This has got to be great. Why would you not do something like that? And that's a lot like the DevOps hype right now, right? We stand up here and we tell you it's going to be good for you. You're going to be faster. You're going to be more efficient. You're going to save money. You are going to innovate everything. You're going to change the internet. You're going to change the world with DevOps. That's the hype. The reality is that I'm going to quit smoking next week. I'm going to be irritable because this is a change. This is going to make me talk to people when I don't want to talk to people. I might gain some weight, put some technical debt into the world, right? Because I have to actually change the way that I'm doing things. I'm going to add and change. I'm going to have debt. I'm going to put on some weight. I'm going to have brain fog. I'm going to be a little confused about this whole thing because things are changing so fast. And I'm used to doing it one way, and I don't know where I am in this process and what's going on and who's going to help me and who's going to stand behind me and do these things. The reality of DevOps, of actually doing it once someone says, do it, is that there's a lot of change and a lot of confusion. There's a lot of pain that goes on. This isn't the magic wand, right? The fairy godmother doesn't come along and just go, there you go. You're now a DevOps organization. So there's a lot of things you have to do to change. Dev has gone through a lot of these changes already, right? They've learned about doing this. And, you know, people like to say kind of blithely, well, you know, developers are lazy. And I mean, yeah, at heart, I am. If I can automate something, I'm going to do it. If I'm going to refactor something, I'm going to use a tool to do it. I'm not going to do it all manually, right? I want to get rid of the yak shaving, and I just want to do what I do, which is build things, get my job done, enjoy it, right? So, you know, we need to look at, you know, how that translates, though, into production. And when we start pushing this model into production, we start seeing that it's not necessarily having, right, the good impact right away. You're in week 1 of your quitting program. It's not happiness out there, okay? Developers, 87% are dealing with delays between development and production. That's huge. That's a big number. 90% of them are taking holidays, weekends, vacations to fix problems that showed up after it went to production. So it was working, right? Works on my machine, works in my test network, doesn't work in production. That's not good. 80% of developers said that they work on fixing just app problems like a quarter of the time. So they're just checking out, you know, tickets and defects, and they're trying to fix them. 43% said over half of their time is spent just doing that. Well, nobody likes to do that. And it's worse when you get it into production because now you have to deal with people who don't really understand necessarily the app and vice versa, right? When you put an app into production, you don't necessarily understand the interaction between it and the 15 different things that have to happen in order to get it out to the user. Why are they having these problems? So that's really the first thing you have to do, right? Root cause. Why is there so much delay? Why are you having so many problems? Well, the two biggest problems, apparently, according to Zend, who did a developer survey a couple of years ago, was deployment into production. There's no automation in it. It's all manual. Get your signatures. Bribe your network guys. Let's get this done. And then the inconsistencies between dev and test and production. And we all know what those look like, right? A lot of times you're just developing on your local machine, maybe on a local server. You're not developing in the actual production environment on those same machines, which can have an impact. In a different network environment with different network variables and different things touching your data as it's flowing through the network. It is changing it. There is almost nothing besides a router and maybe a basic switch that your app is going to travel through that doesn't somehow impact that data. So those kind of things show up in production where they didn't exist in dev. And that causes you to have to spend your vacations and weekends and your nights trying to fix that problem because, of course, it's your problem, right? It's not production. So this is kind of why this is a problem. Because on the top here, we can see, right, this is the way that the network looks at a total deployment, right? In this box is such a complex network environment that it cannot be shown on this slide. And then we show the dev environment. You guys just have like these little tiers, right? This is how a networker views your app. That's it. Okay? On the bottom, we see exactly the opposite, right? You view the network, well, there's a router and a firewall and that load balancer thing, but after that is a complex, detailed application architecture that cannot be shown on this slide. I've had 3 cube walls filled with an architecture. Where it's going, which data sources it's pulling from, who's integrated with who has to talk to who, where's the JMS, where's this, where's that. It's highly complex. The same thing is true in the production environment. It isn't just a straight line. Right? There's a lot of different services that hang off of here that do different things, that check your app for X or Y or Z, or that prevent the user from getting at this and that and the other thing. We got malware, we got viruses, we got performance problems. We got all sorts of things that the network is actually dealing with and manipulating in production that don't happen in the app environment. So we do have 2 completely different environments that we're dealing with. That second problem, the lack of automation, that's huge, right? We got a lot of integration, a lot of automation, a lot of orchestration going on in dev and test environments. We've got Agile, we've got Git, we've got Jenkins, we use Maven, we use Gradle. We use software, we use APIs to integrate all these things together to plug in and have an automated build process, right? Even when you were chaining make files way back in the day without dating myself, right, it was still somewhat automated. Build these dependencies. Now go build this dependency. And you would hit the button and you'd sit back and you'd get some coffee or maybe go, I don't know, go out for a couple of days, come back. And suddenly your app is built and ready to go. But it was all automated. I didn't have to build everything step by step. So developers have been doing this for a long time. It's just gotten more sophisticated and a lot more measurable and integrated with all of these tools. It's a wonderful thing. You're pushing code, what, 1, 3, 5 times a day, once a week, twice a week, 3 times a week, right? You can push that new app like this, and then it runs into this wall. This is production. Oh, no, we don't do it that way. We have manual processes. We have waterfall. 1, 2, 3. We use SSH to go in and configure things. We use bash, consoles. We use hardware and CLIs. And we do all of these things step by step with very specific approvals needed in order to change a system. Now, there's a lot of reasons why that is true. One of them being that most networks in most enterprises today are kind of important, right? I mean, they're the business. If that network doesn't exist between the user and your app, it doesn't work. Everything is networked today, right? We don't load floppies anymore and just fire it up. It doesn't work that way. Everything is delivered over the network. That network has to be stable, not just for the app that you're trying to push, but the other 508 apps that an average enterprise maintains and delivers. And if you mess with that network and it makes something else go down, now there's a problem, right? And they're going to get yelled at for that, and they don't want to be yelled at either, right? Because now they're costing money. Downtime costs money. Outages cost money. Productivity losses cost money. So they're not very excited about changing this too much because they're afraid of interfering with stability and reliability and their measurements and their bonuses and their paychecks and their nights and weekends and vacations. So there is not a lot of automation that goes on in production. Yet we need to get there because you can't put out apps as fast as you need to or changes to those apps as fast as you need to doing it manually. It's troublesome to try and schedule people, right, and then do it in change windows, right? You know how all this goes. It's very painful. Well, I'm putting out this app this day. Well, you can't do that then because this other app is going in that's going to modify the database, and you rely on that database. So first they have to go because they have higher priority than you. And this is how it works. And you say, that's just not going to work for the future because there's only so many Saturday nights in a month. We have to do this more frequently, especially with things like mobile apps, right? Minimum viable product is kind of not a standard, but it's something that a lot of organizations work on right now is let's get something out there that's minimally viable that people will use, and then we'll just keep upgrading it. We'll just keep having them upgrade all the time on their iPhone or their Samsung or their Android, right? Just hit that upgrade button. We'll just keep doing that. And that really works for a lot of people. But to do that, you have to be able to push those upgrades and push those new versions out into production faster than once every, 3-4 months. So we have to do something really to kind of break this fear that production has over that, and organizations and the business too, because they're afraid of the same things, right? I don't want my core apps to get bothered by you people when you're pushing things around. So continuous delivery looks sort of like this. This is a pretty common model. It may be a little different depending on your organization, but everything is automated. It's really sweet, except for that one little piece where it says deploy to production. This is where manual comes in. This is what we're trying to fix. This point, this has to change. So what that should look like, and this is kind of part of the problem right here, is that there's a lot of stuff that goes on in there. Again, if we looked back to that picture, right, there's a highly complex set of services and things, and each one of these requires all sorts of other things. Right? Just about anything that goes on a network requires about 5 different network attributes to be specified. Things like you need an IP address, you need a network mask, you need a default gateway, you need DNS servers, right? You need these things to be configured. Whether you're in the network or you're an app, this has to be configured somewhere so you know how to communicate. That has to be done for each one of these. That's the beginning. Then each one of these things has to further be configured to do what it was meant to do. If you've got an IPS or an IDS that's got to go in there, or some anti-malware, or some phishing checks, or virus checkers, those have to also be configured to do what they need to do against your app. You've got load balancing and identity and access control. You've got maybe some performance optimizations, caching, things like that. All of those need separate configurations. So you're talking about a whole lot of bits that have to be twiddled when you get into production. So it's a long, complex, scary process for a new app. For an existing app, it might just be a tweak, but you still have to go in and modify them, and you have to change them, and that gets to be scary as well. But we need to do this if we're going to get to continuous deployment, so we can get those apps all the way out to the user faster. So what we want to do is introduce DevOps to production. We want to say, hey, there are things in DevOps that can help you do these things faster. Because let's admit it, the network has a whole lot of yak shaving too. I mean, it's not that hard to configure an IP address and a network mask. Most people can do this, even developers, right? They can do this. It's not a big deal. Why is it such a big production in production, right? We need to get them past that to kind of help them to start doing a lot more automation that is going to produce the stability that they need, but give it some speed to take some of that pressure off of them so that we can actually move things through a lot faster without having to involve them in every single thing. So most people at that point go, wait, dev and ops. It says dev and ops. It doesn't say anything about the network. That's something else, right? It doesn't. What are you talking about? this is one of my favorite things to remind people. There are 4 different ops in the network. There are 4. No matter what you say, there are 4. There is security. There are network operations. There's operations. These guys always confuse me. I don't know what to call them, right? Infrastructure operations, ops, I don't know. But they're there. They got to take care of stuff too. And there's storage ops. Now, I don't talk too much about storage. My husband was the storage freak. He knew all of the storage things and how to do all that stuff. And I just went, right, I know I need it, and it's out there. But they have their own operations too. They do all sorts of incredible things today with storage, right? Automated this and that, and they're making LUNs and LANs and all sorts of TLAs that, make it possible for apps to actually run and have access to all sorts of their data that they need. So NetOps has the same issues as DevOps has in terms of being able to automate, share, change their culture, actually become more collaborative, and start measuring things in a way that makes sense to the business, as well as, how fast did we get this ticket closed? Because that's not really that helpful. So they have turret syndrome. They really do. They don't collaborate well, right? They measure different things than developers do, right? They are measured on things like latency and SLAs and uptime. Mean time to recovery might be one that they share with dev and ops, but not much else. They're really focused on, how is my network performing? How are things flowing? Handoffs are awkward when you have to go, because everybody is siloed. The people that are dealing with your security are not the same that deal with the actual network, even though they have to work together because everything needs network stuff, but yet the security guys are still completely different. So they have to hand this stuff off. That means there's approvals between them, and there's chains of command, and you have to worry about, is Bob on vacation, and who's going to take over for Roy, and where is Alice, because she was supposed to do this today. Well, she's out sick. Sorry. That's been my experience in the enterprise. That's how it worked. You really had to deal more with people and handoffs that caused bottlenecks in this process than you did with the actual technology. The processes are inefficient. Okay? And that's the whole, I have to manually go out here, I have to SSH into here, and I have to change this configuration, and then I have to save it, and I have to make sure it's all good. It's a manual process that doesn't need to be manual anymore. That should be automated or automatable, right? That should be a lot more collaborative and being able to just kind of push buttons. It's the cloud, right? That's what cloud really gives us. I mean, if we really broke it down and said, why do people like the cloud? It's because all that network stuff that still happens is not our problem, and we don't have to deal with it. It's just magic. I push a button and it happens. And that's what they want in the enterprise too, right? That's what they want. They want to be able to push a button and have it happen. But it takes some work to get there, and DevOps can help get the network to a state that is at least, if not perfectly cloud-like, at least more similar in how it's running. So one of the problems we have is that there's a rich, a robust portfolio of tools available for dev, right? This is not even a small number of them. I mean, everybody's got their own tools. Our own dev people, and we've got dev across, hardware. They do software. They do everything. They use Juju, and they use, Gradle and Maven, and they're out there doing these things. I never heard of Juju before they started talking about it. I'm like, what is Juju? That's a fruit. They're like, no, this is a cool scripting thing we do. I'm like, oh, okay, well, that's pretty neat, right? But not everybody uses Juju. Right? Not everybody uses Jenkins. Not everybody uses X or Y or Z. There's just so many different tools for people to use based on how you're building it out that you have a lot of different choices. So it's really easy to build this chain and get this integration down and actually get things moving. In the network, we got, well, not much. Well, Jenkins doesn't really work. And Gradle and Ansible are cool if you're doing software stuff. But most networks aren't completely software. I'm going to say this. This is my controversial statement, okay? Software defined does not mean software deployed. It means I'm going to be pedantic because that's my superpower. Software defined means that it's controlled, managed, changed, altered, configured via software. It says absolutely nothing about what the underlying platform is. Now, everything has to have hardware somewhere, right? You got a server somewhere. Memory didn't just fly out of a unicorn, right? I mean, it's coming from somewhere. Same thing with your network and your storage. All these resources are coming from somewhere. So that might be a commodity, right? Just picked it up at Best Buy server, or it might be something that somebody built. Irrelevant, right? It's in there. It can't be deployed generally as just an image. There's no image for half of the things that run in production. So you can't just, Vagrant or Ansible off a VM and just shove it into the network. Generally speaking, not in a real enterprise, in an existing enterprise that has an existing network. That doesn't happen. So we need different tools. We need something else. We need something that looks like DevOps and acts like DevOps, but that isn't what dev would use, because it's not going to work. Plus, it requires code. Network engineers get very, very, very antsy when you mention something like code. If you say script, then they might be okay. But if you mention code, forget it. You're done. There have been numerous attempts to put all sorts of interesting things into a network and say, you can program it. Let your developers change it. You know what they said? Oh, no. Are you crazy? Not going to happen. And they didn't let it happen. I mean, entire products have been conceived, marketed, blown up beyond belief that never actually made it to manufacturing by the vendor because there was such a lack of interest in the network for actually letting someone mess with it, right? So code is not necessarily it. Scripting might be good, frameworks, right? Things that can control it, that do what DevOps does, but doesn't require the same level of, perhaps actually writing integration or writing these scripts. Unfortunately, a lot of times when people in DevOps get excited about it and they want to push, they want to say, hey, we have all these tools. And usually they're using examples like Netflix or Google or Facebook, and they say, hey, they did it. They use all of the software tools, and they basically dev'd their network. Everything is DevOps to them, right? Unfortunately, or maybe fortunately, enterprises are not Google or Netflix or Facebook or PayPal. They have 508 apps. They have a lot of infrastructure that they've already invested in that run their business, that the business is not willing to give up. So the same tools that work for them are not necessarily going to work for traditional enterprises. The concepts will. The culture change will. The methodologies might. But the actual tools are probably not. So you can't just give them your hammer and say, go at it, because they don't have nails. They've got screws and bolts and wing nuts and lag nuts, and I'm a carpenter's daughter, can you tell? So, I mean, I can go on. Roofing nails, right? Those are different. You need anyway. So what you have to do is really add some more tools, or give them some different tools that they can use to achieve the same goals as DevOps, but just using things that fit into their environment more naturally. Because the alternative is to turn everything into production to look like dev. Well, we just established that probably not going to work because there's too many apps relying on what there is today. So you can't do that. And we really can't turn dev into production because that'd be really, really, really super, mega, uber expensive and hard. You'd be running 2 data centers. It's just not financially feasible. So we need different tools. So then we start hearing about things like software-defined everything, right? If there's software-defined security, there's software-defined networking, which started it all. There's software-defined data centers. There's software-defined storage. There is software-defined WAN. I think there's software-defined LAN. I think there's software-defined everything, right? Half the things in my house are probably software-defined. And what that means is really, it started out as a concept of we're going to program everything. We're just going to turn the developers over and let them just make switches and routers and network stuff, do whatever it is they want. And it took about a year for them to go, that's probably not going to work, because nobody actually wants to do that. What they want is a way to automate the network. Right? They want a way to be able to control these things using software tools because they're more flexible and they can be customized easier to fit into my processes and my environment and the way that I want to do things, because it's software. Software can do anything. So that moved all of the software-defined X, whether it's DC, WAN, SSC, put whatever you want on the end. All of it is really now about how do we operationalize the network using tools that fit into our environment. So how do we do that? How do we take the principles of DevOps and slap it on top of the network and make it more efficient and faster and reduced risk and get some of the stability that is rarely talked about in DevOps? We always talk about fail fast and break things, and this enables you to do it faster. But we also forget that by doing that process so often and having it codified, that we gain a level of consistency and stability that the network needs and wants and the business demands. So we actually want to do that. I mean, if you only do something once a year, right? I mean, everybody says if getting back on a bike, right? It's real easy, right? Right? Come on. The first time you get back on a bike after 20 years, you're wobbly. You're like, I'm not sure I can do this. How did this be so easy before? And it takes a little bit of time, and then you pick it back up. But that's if you're only deploying once a year or once every 18 months. And you get that same thing. Oh, what's the process for this? How do we do that? You're bound to make mistakes. Human error, you're going to mistype something, you're going to forget something. Something's not getting done. So by going to a more software-defined, software-driven model into production, you can get a lot more stability because you're doing it all the time. You start seeing things like inefficiencies. Why are we doing that? Wow, did you know that we actually do this step like twice? Well, that's kind of inefficient. Let's get rid of that. You start optimizing that process, and the handoffs become more efficient. There's less friction because it's no longer I need an approval. This is part of an approved process that takes us from delivery to deployment. And now we can just watch it run, make sure everything's okay, and then go kick back and grab some beer. We're good. So SDX kind of fits under, if you look at the two environments, right? You got dev. Continuous delivery is about taking, and I know there's more groups under dev. The slides are only so big, right? So I'm guilty of minimizing here. But there are groups, and they are tied together, and they enable continuous delivery, which is shoving it up through dev and saying, here it is. What we need on the other side is for all of those groups to take advantage of things like software-defined X, Y, or Z, and to push that up through ops so that together we can get continuous deployment. Push button, start to finish, happiness, joy. So one of the ways that we're going to do that is we're going to start treating infrastructure as code. There are a lot of definitions of this. There's definitions of what it isn't. When I look at it, this is kind of the way I break it down, is there are two components to infrastructure as code, right? So there are APIs. Almost every network device, thing, box, appliance, whether it's hardware or software today, has a set of APIs. They are now, you can drive them from anything. You could drive them from your app. I've done that. It's really fun. You just power up your app and start telling the network what to do. You can make a mess doing that. I don't suggest it, by the way. So APIs, right? Call by call. I'm going to do all my steps in my process. I'm going to do it one at a time, which is comforting for some people. A lot of vendors have basically taken, I'm just going to take my CLI, my command line interface, and I'm going to put an API over top of it and let you do it that way. So that the network guys who are not really all happy about this whole, I have to learn APIs and REST and I have to do things, can still just fire up curl and be able to do what they need to do in a nice little script that is still more efficient and faster, but yet comfortable, right? So they can make that transition toward being more automated. It is step by step if you use an API. You are going to be, step 1, step 2, step 2, and the configuration is still stored on the device. This isn't something you like dump out. I mean, you probably back it up. Most people have a backup system. And sometimes. I mean, sometimes you forget. If something breaks in between backups, you could be in trouble. But the configuration is generally on the device. The entire process here is driven by the API. So they can use tools that they're comfortable with, that they already use, because they do scripting, or it could be driven by maybe a less traditional organization who is using, right, other kinds of tools that can integrate with an API. So it kind of works both ways. The other thing that we're starting to see a lot more of, and obviously I approve of a little bit more, is the concept of templates, because this is a little bit more like your golden image, right? It's more of it really is infrastructure as code, because all of the settings that make up this thing for this app on this network device get codified into this nice, neat little package that can be stored in GitHub or in some other repository or on the network somewhere, on a file server even, as long as it's somewhere else. Plus, you have the advantage of the entire configuration is in one thing. You only have to really make 1 or 2 API calls to get it out there. So there's no API tax here. Right? Instead of like 15 calls, you're making 2. Well, that's better. That's faster. Right? It's easier to check, better to watch. You do it all at once, and the configuration, you store it off device. You almost have to, because that's kind of the premise, is that we can actually put this into a repository that is accessible, kind of the way we do code, and then drive that process, build the code, grab the configurations, deploy things. Ta-da, we have an app. And it's ready to go. It also means that you can back up, right? The notion of immutable infrastructure in DevOps. Good idea, if you want to go that way, right? The notion that once it's deployed, this machine sits here, it does not get changed. Because we have a copy of it over here. And if you change it, I'm just going to push the new one back out. It's fixed. This is not a problem. Same concept ends up in the network, which makes it a lot faster when you're deploying things to be able to go, wow, something broke. Somebody did something wrong. Quick, put it back the way it was. This notion of a reset button, a rollback in the network is different. That's not something that generally happens. So it's really good for them to be able to have that, because that gives them confidence, right? That if they make that change and it goes wrong, they can just flip it back. So it's not a big deal. They're not going to have 4 hours of outages while they try and run to the switch and figure it out, right? I can just push it back the way it was. And they need that level of confidence to keep that stability, to make the business happy. So these things enable that idea of treating infrastructure more like code, no matter what it's deployed on or looks like, so that we can actually kind of get to that model of DevOps, but do it with NetOps. So these are kind of the two models and where they fit, right? The declarative model and the imperative model, right? Imperative, right? You're making explicit API calls, many of them. And this usually comes out of your orchestration, your cloud stack. So OpenStack would do this. Open Daylight would do this. Your cloud would do this, right? You've got something that is driving this orchestration. Because that's the other thing in the network. There's just like the dev. There's no super orchestration master out there yet. Not for the network stuff. They have to plug into something higher, because something higher will also be able to deal with the compute in the app and pushing these things through the network. So they have to be able to tie into something, right? And that gets up there. The declarative model is more, it's a template. It's a policy. Policy-driven networking, and that goes back to like 2001, 2002. Cisco used to push that really hard. Policy-based networking. We're going to do this. Everyone, whatever. Now we call it something else, and suddenly it's cool. But this is the model that things like OpenStack is driving to with heat templates. It's what Open Daylight is striving for when it starts looking at how do I use OpenStack's like policies and group policy things to push into the network, as well as into other pieces of the network. VMware uses very much templates when it starts pushing things out into the network as well as into the actual application infrastructure. And Cisco uses this model when it puts it into the network and just configures network devices. It's very much about tell me what I should do, not how to do it. And we'll let everybody else do it. So either of these models works depending on what you're trying to do in the network and getting it there. I'm a fan of the declarative model just because it's less taxing and it fits better into a DevOps model, I think, because it has that concept of kind of golden something, right? There is a master and it's stored off and it can be treated like code. So one of the things that DevOps can do and an organization can do in order to start moving production toward a DevOps environment is finding commonalities in those tool chains. And it also helps encourage some collaboration. Because if I want to use Git, which admittedly is pretty simple, right? If you're used to it, right? If you go out there and you go, oh, this is easy. I know how to push, I know how to commit, I know how to do these things. No big deal. Well, the network guys don't necessarily know that. So there might be some conversation that goes on. How do I use this to pull my code or store my policy or store my template and then pull it off, right? So there's a little bit more communication about that. For many network functions that are becoming more virtualized, right? A lot are still deployed on hardware, but many are becoming virtualized or are today and can be deployed as a virtual image, if you will. Use the tools that DevOps uses, right? Standardize. Start using the same kind of system to build up toward continuous deployment. All of the SDX relies on the other API ecosystem. That's what I like to call it, the other API economy, the one that's kind of hiding inside the data center. And that is things like, how does Red Hat enable, right, all of this ecosystem? Well, a lot of it is through APIs and integration. It's the same way that software has always enabled an ecosystem, is through some form of integration. And right now, that form of integration for just about everybody is APIs. And it's consistent across the entire data center. Everybody is using APIs to do this, which gives us an incredible chance to actually unify a lot of the processes that move from dev all the way into production, and to make that process a lot smoother. Maybe not seamless, at least not at first, but at least we can get it, right, a lot less bumpy. We can smooth out some of those bumps in the road that happen and get them actually moving at a consistent pace from one environment to the other where they need to be. So finding these commonalities will help you leverage existing skills and expertise as well as tools, because nobody wants to hear I got to spend another X amount of money of my budget on new tools, right? So if there are tools, use them. If there aren't, you're going to have to find them. Then you're going to have to make that investment, but it'll be worth it to get to that point. Look at the different options out there and see how do they fit together. Where can I find some synergy, to use a buzzword? We don't have buzzword bingo here. I'm so disappointed. But to find those places where you can actually work together and get some of that collaboration that's going to enable some of that cultural change. Right? Because culture isn't just, the C-level guy doesn't come out and go, your culture's changed right now, that's it. You're now all DevOps. Everybody in the whole organization. And everybody goes, oh, what does that mean? Right? You can't enforce culture from the top. Culture is built by action and by the people that actually have to do it. And if you want to build a culture of collaboration, you have to encourage that in the first place. And one of the ways to do that is to go, look, we need production to be as fast and agile, while remaining stable, as development. So let's get these guys together talking about, well, how do you do this? How did you handle this problem? Get some of that collaboration going on and foster a little bit of better understanding between the two, right? Because not everybody, is a crossover that, can understand both sides of the fence, right? There's still a lot of finger pointing going on. So if we can cut that down, that culture will come naturally. And that will help, get everybody moving in the same direction, which is to get DevOps into production so that we can get apps into the marketplace. And this kind of sums it up. This is what we're looking for, right? What production needs out of DevOps is consistent, predictable, repeatable deployments, because that's going to decrease error rates that cause outages and problems. That's going to increase or decrease the time to deploy. So it's going to make it faster, which is going to make everybody happy. And it's also going to allow a greater frequency, which in turn feeds back into lower error rates and faster time to deploy, because the more you do it, the more you're going to get better at it, and you're going to be able to optimize it, and you're going to be able to figure out where the bottlenecks are and eliminate them. So if you haven't started or thought about it, or your network guys haven't, they need to start thinking about how to do this, because this is really, it's not going to get any better until we move some of this DevOps stuff into production, into the network, into those 4 ops, and get them applying those methodologies and actually being able to scale out operationally and help the business grow as fast as the apps would allow them to if we could only get them into production in the first place. So thank you. I have no idea what time it is, but we're done. So I'm supposed to inform you, you can ask questions. I don't bite most of the time.
I just said tough crowd.
It's. I've had tough crowds before. Nobody threw tomatoes. I'm good, really. I mean, that's kind of my bar, right? All right, well, thank you all. Oh, you do have a question? Sure.
Lori, I'm familiar with project collaboration type applications to help teams developing projects communicate, across teams, things like that. Is there any kind of collaboration tool, maybe coming out of the DevOps that would allow application people to work with ops people, maybe issuing tickets, against work to be formed or defects found on either side? Is there any, sort of a formalized application for that kind of collaboration between applications and operations?
I don't think anything's been formalized. I think they're usually, at this point, using the tools that have been in place, right? Doing tickets, sending them through queues, which has been really kind of inefficient, right? Because you're relying on just, right, who got it and did it get in the queue? You don't really know. All of that needs to be improved. There's no standardization there. I know a lot of organizations are moving to things like actually using, right, Slack and communication tools where, it's like your Twitter stream, right? You see things going by. You're not obligated to respond, but if somebody's saying, hey, something is wrong, you're kind of getting, it's like the tornado siren going off before it ever gets there, right? So before the ticket's even there, you've seen that it went by, right? And somebody's going to pay attention to that, and they might start looking into it right away or having a conversation before the ticket gets there so they know what's going on. So decreasing that mean time to resolve. In terms of actually managing the continuous deployment process, so Dev has this entire organization, and my mother was a project manager certified and all that, right, for 20 years. And right, they have PMPs. and they do Six Sigma and Lean and all of these formalized processes that drive projects. You get the network, you got a spreadsheet and a guy in the back room, and that's it. You don't know what's going on. And I'm a real big proponent of taking something like Six Sigma because it's so based on a lot of, what are defects, outages, times. It's very mathematically driven. Very nice for engineers. I liked it. As a way to start helping to kind of manage projects of this nature in production, because that's one of the things that they need to be able to do is see the big picture. And right now they don't. So I think, of all of the non-techie type of technology that can help get DevOps into production, one of them will be kind of pulling those project managers and teaching production how to manage deployments in the same way that we manage application projects. Right? Not Scrum. We don't want can boards in the network. That's kind of how it works today, and it's not going so well for them. So maybe something a little bit more formalized will be better for them, especially in the enterprise. I think that's a good place to start, is more with that management, just so they can see the big picture.
One of your slides illustrated the declarative model and the declarative model.
Yes.
I was wondering, the message in that slide, were you trying to illustrate a shift in API call versus templates, or were you trying to focus, or was your message focusing on something else?
Did I have a message? Yes, I did. Yes, well, I would like to see it shift, and I think it is. I think the market and the general trends right now is shifting toward the declarative model. So we saw that, the first model was, I'm just going to use APIs to do it. And the problem with that is that, I work for F5, so we have one set of APIs to set up a load balancer, right? Citrix has an API, and it's completely different how they set up a load balancer. Nginx, everybody has their own APIs and their own models. So they have their own object models for how they deploy these things. So if you use an API and you're not a single vendor shop, you are going to have 15 different API-driven scripts to set up each different system. And what if you want to change? What if you started out on Nginx because you didn't need that much, and then you went, wow, I really need some more power, so you went to somebody else. Now you have to rewrite all those scripts, right? The technical debt, the architectural debt inherent in the imperative model is incredible in production. And we have to try to avoid that if we can. But it's only been recently that really the concept of using templates. I said like heat templates, Cisco APIC uses a different policy type model for how it deploys things, but it uses a policy. So it's all about, I want you to set this thing up, and then it just kind of pushes it out and says, you do it. I don't need to know your object model or your API, how to do all these steps. Just do what I told you to do. And so I think in the long run, that's going to be better, and that will actually get the production to DevOps or a DevOps model a lot faster than it would the whole, I have to hard code basically everything. Because is that really all that much different than manual when you get down to it? And the change and the cost there is pretty high. And if that's all you got, go with it. But if you haven't started and you're ready to look at it, I'd start looking at those template-based systems and how you can use those instead to kind of insulate yourself from getting locked into X, Y, or Z too. Well, thank you all. Class is dismissed.